Hi everyone. Today I want to discuss my paper, Hierarchical Instance Tracking to Balance Privacy Preservation with Accessible Information. Many people who are blind use camera-based services to learn about their visual surroundings, as shown from the example application Be My Eyes, where the user points their camera and records everyday life. However, undesired privacy leaks can emerge when users share videos with 1. Another person, or 2. A service provider that records their data. However, what if a user wants to share data, but there is private information in the video? So the challenge is balancing privacy preservation while retaining the information users are seeking. To enable minimal obfuscation, we present a new task, Hierarchical Instance Tracking, or HIT. This unifies video instance segmentation and part segmentation. It tracks instances of objects and their respective parts while maintaining their hierarchical relationships. To support this novel task, we release a new dataset. So the figure to the right is an example of our dataset that shows an object and all of its parts segmented and tracked over time. So our dataset BIV-PRIV-HIT is the first public dataset challenge for the HIT task. We provide segmentations and labels for objects and their respective parts in videos. As you can see, our dataset is the only one among entity part tracking datasets that contains semantic labels, hierarchical tracking, and part tracking. The example below shows how our dataset can be used for benchmarking and fine-tuning other models. We propose a new evaluation metric that can assess how well models can preserve the hierarchical structure between an object and its parts throughout tracking. So we came up with a new penalty, specifically hierarchical identity switching, in which we penalize the model if a predicted part ID changes or if a predicted parent object changes. So our results were that we benchmarked 3 types of models. The blue models are hierarchical segmentation models, which performed extremely poorly as it could not identify any objects or parts. The next set were video instance segmentation models, which also struggled. Finally, we benchmarked video object segmentation models. As these models have no semantic knowledge, we cheated by giving these models the ground truth segmentation for the first frame. In this way, SAM2 fine-tuned on our dataset did the best. Even our top-performing model, SAM2, still struggled in certain scenarios. The top example shows SAM2 missing several parts due to the occlusion, while the bottom example shows SAM being unable to identify the object-level mask due to extremely low lighting and small parts. In conclusion, our dataset offers a new challenging problem for the research community. Thank you so much for listening.